The city of Miami Beach is bounded on the west by Biscayne Bay, on the north by the city of Surfside, on the east by the Atlantic Ocean, and on the south by Government Cut. In addition to its own wastewater service area, the city accepts wastewater flows from 4 municipalities: Bal Harbour, Surfside, Bay Harbor Islands, and North Bay Village. The wastewater is accepted into the Miami Beach wastewater transmission system, and the flow is conveyed through a forced main and booster pump station transmission system. The ultimate discharge from the sanitary sewer force main network within the city is through a 54-inch diameter line. This line begins at PS1, located on 11th Street, continues south on Michigan Avenue towards South Point, and passes beneath Government Cut to the Central District Wastewater Treatment Plant at Virginia Key. The city of Miami Beach decided to construct a redundant 54-inch high-density polyethylene force main using an innovative design-build approach. This line was constructed 40 feet below the historic Euclid Avenue using horizontal directional drilling, also known as HDD technology, to minimize construction impacts on the residents and local businesses. Directionally drilling the redundant force involved approximately 4,340 feet of 54-inch DR17 HDPE weighing approximately 225 pounds per linear foot. Until this project, directional drilling on this scale had never been attempted by the city of Miami Beach. The installation of approximately 750,000 pounds of HDPE required creativity, experience, and teamwork. This project established a new record for the city, as well as the state, regarding the length and size of pipe installed by HDD. This achievement is the result of the coordination efforts and collaboration between the city of Miami Beach, the contractors of David Mancini and Sons, and the engineers of APCTE. The horizontal directional drilling and pipe designers of Brearley Associates, Hard Rock Directional, and Spartan Directional also greatly contributed to the success of this project.
The city utility serves approximately 113,000 people. We are anticipating that to grow in the next 20 years to 140,000 people. So one of the challenges we had with the growth is we also are close to the ocean, and we have a well field that we pull our potable water from. In Florida, we have a very porous environment aquifer. And so as that water is being pulled out of the well, it's pulling that ocean salt water into the well. So the only other place we can go is to move west. So the city also owns a water plant and a well field west of 95. We'll move that water to the east plant, treat it where the growth is, and then put it back out to serve the growth that's going to occur. The problem is when you do that, it's a different source of water, meaning it has different parts in it, different things in it, so we have to provide different treatment. This was actually a great project for design build. We pulled the best brains in and said, what is the best way to build this project? So we were able to make decisions actually very quickly based on real numbers and real cost, and still have complete control over what we wanted built.
We did a lot of things along the way to reduce the actual cost to the project. As a result, we showed about $3 million worth of savings. We were able to put in the LED lighting, which was a big concept for the community, but it was not part of the original project. The artwork at the front of the park is going to be a constant reminder of what's going on at the facility.
CDM Smith does a very good job listening, acting, responding, and fixing problems when they come up. Yeah, this project's going to give the community the ability to grow, which it needs to do. If you don't have your basic infrastructure in place, you can't function that way. You cannot grow. I think the other thing it does is it guarantees the citizens and the customers that in their lifespan and their kids' lifespan, they don't have to worry that they don't have a reliable source of water. So that's really important to us as utility executives, to make sure we give that confidence to our customers.
The I-95 at J.T. Butler Boulevard is a shining example of the spirit of teamwork along with the desire to explore innovative ideas. The intersection of I-95 and J.T. Butler is a major interchange south of downtown Jacksonville. I-95 carries traffic north and south through the heart of Jacksonville, while JT Butler carries traffic east and west to the beaches on the Atlantic coast. The project included a free-flowing southbound exit ramp from I-95 to eastbound JT Butler, combined traffic operations of 2 closely spaced interchanges along JT Butler, and added ramp capacity. The results are increased capacity and much safer operational conditions. The project included numerous innovative ideas. The team proposed to split the southbound I-95 off-ramp such that the eastbound flyover ramp was segregated from the westbound ramp. This resulted in a considerable reduction of embankment and elevated structures. Most important, it provided an envelope to place the future I-95 southbound managed lanes. The team proposed to realign Ramp E and Flyover 2. This resulted in the considerable reduction of elevated structures. It required a straddle bend configuration, however the team was able to use shorter fib spans rather than steel. Notably, the most important innovation for this project included the post-tension curved concrete U-girders. This technology had never been used by the Florida Department of Transportation. Splice girder bridges are typically used for continuous structures in order to facilitate longer spans. In the past, splice girders have been limited to straight concrete I-girder sections. New spliced U-girder technologies now allow for curved U-shaped bridge options. Curved concrete U-girders offer a reduction in long-term maintenance, competitive design parameters versus steel bridges, and are aesthetically attractive. This technology is now being considered and implemented on projects throughout the state of Florida.
The existing bridge was old, it was past its design life,
and was starting to cost the department a tremendous amount of money in maintenance.
You know, as we led up to the development of the Sisters Creek Bridge replacement, really everything about the project was a challenge.
The environment, the environmental protection, both the salt marshes, Sisters Creek, St. Johns River.
Just the overall construction in the river.
Tremendous tidal issues there, tremendous currents.
This area happens to be one of the most pristine salt marshes in all of Florida.
The technical aspect of the bridge itself and what the engineers had to overcome relative to the foundations and the design and the challenges and the capacities.
Just the construction itself in such a massive scale is difficult, with over 21 spans and 21 piers standing as high as 65 feet in the air.
We had 3 large piers that we had to construct in the river with some difficult pile driving to get them in. The girders that are part of the bridge in the river were some of the longest Florida I-beam girders that's been cast to date.
We chose high-strength concrete girders over steel girders for this environment because steel girders tend to corrode. There's a high chloride content in the water, and we just didn't feel that it was appropriate for this site.
By eliminating the bascule bridge, having to stop traffic every time we open for marine traffic, it greatly enhances the travelability, the evacuation route, the time constraints for the area.
One of the things that really makes this project a success is how we were able to blend in the environment and the recreational facilities to make this more than just a bridge, but a destination.
The Sisters Creek Bridge will be one of the top projects in my career.
Sisters Creek Bridge is such a success because of the efforts of the team and what they overcame. From the technical aspects to the public information aspects to the environmental considerations, the constraints, all the neighbors in the area and all the opinions, they overcame and they conquered. They did a fantastic job working as a team to overcome the challenges put before them.
Sunset Harbor in Miami Beach is one of the coolest projects I've worked on in my entire career. Very proud of it. The project started with a general approach of helping them take care of some flooding situations. During seasonal high tides, and especially if there's a rain event that happened, the roads would flood and they would stay flooded for 2 to 3 days. So of course, the visual effect is that we can see that the streets are raised here, but there's also a lot of infrastructure that had to happen beneath the streets for this project to be successful as well. We added 1 new stormwater pumping station. We upsized a couple more. And we also put in a large diameter network of stormwater collection pipes beneath the street. If we're going to keep this area dry when it rains and during high tide, we have to have the ability to move a lot of water. So beneath these streets, you'll see catch basins, inlets along the sides of the street. And if you were to cut a cross section, you'd see a 36-inch diameter storm sewer. We go up to 54 different places throughout the neighborhood. We're here literally standing on the site of pump station number 3 in Sunset Harbor. Now, although this isn't one of the most beautiful features of the neighborhood, it is absolutely the most important. In this pump station alone, we can move about 15,000 gallons per minute of stormwater, and that can handle a 24-hour, 5-year storm with 6 inches of total rainfall. The Sunset Harbor neighborhood in Miami Beach is the first project in the United States that was a direct response to sea level rise. And it brought a lot of national attention, and it got people talking about sea level rise and the fact that we need to be looking forward and figuring out how to build more resilient systems and make sure that we're prepared for that change.
On a remote island in the South Atlantic Ocean between Brazil and Africa is Ascension Island. Home to the auxiliary airfield and support facilities built in 1939 and currently serves both the United States and United Kingdom's Royal Air Force. The runway facilities needed a full-depth replacement. The first project step for DRMP surveyors to perform all of the surveying and mapping data collection. The island's remote location was only one obstacle. Add in complicated volcanic terrain, shipping in all equipment and materials, and survey personnel who only had 14 days to collect all data and ensure accuracy. There would be no return trips. Deploying the latest in surveying equipment and technologies was DRMP's answer to increase data accuracy and collect it quicker. With the use of truck-mounted static terrestrial LiDAR scanners, survey crews scanned over 2 miles of runway, developing a point cloud of data. While this crew was scanning, another was using an unmanned aerial system, UAS, to collect photogrammetry imagery to cover 500 feet outside the runway. Using ground-penetrating radar and utility locators, subsurface utility engineering crews performed utility designation and location of over 6 miles of underground utilities. Surveyors performed a topographic survey of the existing pierhead and beach area to facilitate the delivery of construction materials and equipment for the construction phase. The crews performed an interior-exterior laser scan of the airfield fire station to generate a point cloud for importation by GIS analysts into Revit and ArcGIS. Together, this data produced a 3D representation of a design-level topographic map with new UFC-compliant GIS airfield obstruction imagery surfaces. This project posed many obstacles that were successfully met by the surveyors, who experienced a chance of a lifetime to survey Ascension Island.
Bok Tower Gardens, a National Historic Landmark and Central Florida attraction, is located on more than 200 acres of land on the north side of the city of Lake Wales. Bok Tower Gardens has been visited by more than 23 million people since its opening in 1923. From 2013 through 2015, the gardens raised more than $15 million for its largest expansion in 85 years. As the lead records civil and environmental engineering firm, Pennoni provided engineering designs and infrastructure support which were used to construct a number of elements such as the new children's garden and the recirculation and artificial wetland treatment system. Pennoni provided planning and engineering assistance for the new core garden entrance area, which was redesigned with safe accessible walkways, a new cafe expansion, and a new shuttle path. These areas were carefully surveyed and designed by Pannoni using a 3D digital terrain model for slope accessibility compliance, runoff protection assurance, and minimization of soil vegetation disturbance. Pannoni performed the surveying and engineering for more than 8,000 linear feet of paved accessible paths throughout the core gardens. Pannoni's engineering and planning included the design of a gentle grade from the visitor center building to a spectacular new special events oval lawn with a 700-foot perimeter, 10-foot wide walk, which connects guests at the new visitor center cafe and pollinator garden to the new outdoor kitchen, classroom, children's garden, and wild garden. Because there is no central wastewater conveyance and treatment system within more than a mile of the gardens, Pannoni designed the area's largest on-site, low-pressure, dosing sewage treatment and disposal system. Alongside the architectural firms of Nelson, Bird & Waltz, Pannoni provided the design and permitting assistance for the supporting infrastructure for the new classroom building, outdoor kitchen, edible garden, and restroom facilities. These areas connect farm to table and are a welcoming destination for educational events. Pannoni provided infrastructure engineering and permitting for the 4-acre multi-purpose children's garden. The children's garden is a place of hands-on fun, natural beauty, learning, and creative play. Pannoni performed the design of a 450,000-gallon, 8-foot deep man-made surface water, which provides habitat and an ecosystem for native plants and wildlife. Pannoni assisted in the design elements associated with the 8-acre wild garden. The wild garden is a haven and habitat for more than 170 different Florida common and endangered plants and wildlife. The new artificial wetland was designed as a part of the water recirculation system, which conveys water from the on-site man-made surface water, or lake, through a pumping and microfiltration system. Water is then conveyed to the on-site artificial wetland. A special fired clay media developed by the University of Central Florida was installed in the artificial wetland for sorbing pollutants from the newly designed surface water. By utilizing the microfiltration upland flow wetland system, pollutants are removed from the water, thereby improving the water quality and reducing the potential of eutrophication.
The I-91 Brattleboro Bridge, a bridge to nature. On September 12, 2017, the Vermont Agency of Transportation opened a new gateway to nature in Vermont. This signature bridge, inspired by Vermont's natural beauty, is the largest bridge in Vermont's history and creates a special gateway into the state. The new 3-span, 1,036-foot-long arching bridge has a 515-foot main span, which soars 100 feet above the West River. This postcard-worthy bridge has viewing platforms for pedestrians, hikers, and visitors at the base of each pier overlooking the West River's mountainous valley. True to its theme, a bridge to nature, every detail of the uniquely shaped superstructure, piers, platforms, and railings complement the natural landscape. In addition to its openness and impressive scale, it catches the eye with towering quad wall piers which represent trees. The quad wall piers are comprised of 4 concrete columns that each curve outward in 2 directions symmetrically. They have a constantly changing cross-section and reinforcing patterns and directly support the concrete box girder superstructure. The underside of the superstructure, a uniquely designed dome shape that runs the length of the bridge, is stained blue to match the landscape of the sky. The quad wall piers also provided proper stability during the balanced cantilever construction of the main span superstructure, which allowed the bridge to be built over the West River and State Route 30 without the need for temporary props in the river or roadway. This provided uninterrupted use of the river and roadway during construction. Visitors can walk between the massive 70-foot tall stone textured columns, which are both functional and structural works of engineering and art.
Interstate 75 at University Parkway Diverging Diamond Interchange. The first of its kind in Florida, the Diverging Diamond Interchange, or DDI project for Interstate 75 at University Parkway began design on April 16, 2012, while the project's construction was unfunded. The project was later funded for construction on October 9, 2014. The groundbreaking ceremony was held on September 2, 2015 to meet an aggressive 2-year construction schedule in advance of the International Rowing event held the week of September 3, 2017. The Interstate 75 University Parkway interchange offers 6 lanes in each direction through the core of the interchange. Traffic was open to the public on May 21, 2017. This was just 5 years and 1 month from the start of design. This truly speaks to the partnerships and teamwork that went into the initially unfunded project. By using the largest acro bridge in FDOT history, the team shifted traffic off the Interstate 75 bridges one at a time, allowing accelerated demolition, faster construction, and maintained safety. Construction was further expedited by eliminating temporary critical walls by using steel sheet pile walls in the permanent location. This enabled faster removal of the second existing bridge so that DDI crossover work could be accelerated. After construction plans started for University Parkway, FDOT made plans for 3 more DDIs along Interstate 75 in Sarasota County. University Parkway's success gave FDOT the confidence to pursue additional DDIs across the state. The new DDI reduces wait times by more than 950 hours, saving an estimated $12.1 million annually. It also eliminates 12 conflict points and is expected to reduce the crash rate by up to 60%. In its first year, the crash reports show a 40% decrease in crashes and 72% decrease in incapacitating injuries. The project initially caused concern for residents and local officials. The team's voracious public outreach, including project renderings and a 3D video, eventually achieved buy-in that the design would be a simpler, cheaper alternative to solve traffic congestion. The residents of Sarasota and Manatee counties are now extremely pleased with the performance of this DDI. The first DDI in Florida and largest in the country was completed on time, overcame technical design constraints, public concerns, and government funding uncertainty. The project makes commuting more efficient and better for the environment while enhancing driver safety.
the world of engineering, bridges mean steel. Tons and tons of steel.
The measurement of those points.
But now, the University of Miami's College of Engineering is completing work on a bridge to the future.
We're rolling.
A 70-foot-long span, erected, engineered, and standing today without a drop of steel. No steel means no corrosion. It's the first of its kind and appropriately called the Innovation Bridge.
Is also made with these materials.
Under the direction of Professor Antonio Nani and Dr. Guillermo Clare, engineering students and other COE faculty partnered with local engineers, contractors, and suppliers to see the historic experiment go from lab to life. As corrosion around steel rebar grows, it eventually cracks the concrete in bridges and foundations, creating massive maintenance costs and even failure. In the lab, young engineers test the endurance of FRPs, shorthand for fiber reinforced polymers, the steel substitutes used to support the new bridge. The FRPs can be molded into any shape and can arrive pre-assembled from the factory.
It's cosmetic.
The advantages to building with composites are extensive. FRPs are stronger than steel, some by as much as 50%. They weigh just 1/4 the weight of steel. When mass-produced costs the same as steel manufacture, and no metal means no corrosion and no costly maintenance. And the Innovation Bridge is just the beginning. The University of Miami has partnered with the Florida Department of Transportation to bring its game-changing technology to a new vehicular bridge north of Tampa, continuing UM's mission to always bridge to the future.